So welcome students. In this video we are going to study one of the most important amplifier circuit in analog circuits, RC phase shift oscillator. So this is a very important topic in electronic circuits. First let me ask you a simple question and discuss. Can an oscillator generate an AC signal without giving any input signal? The answer is yes. So unlike an amplifier which requires an external input signal, an oscillator generates its own AC waveform by converting DC energy into AC energy. So that is why oscillators are called self-generating electronic circuits. An RC phase shift oscillator is an electronic circuit that generates a sinusoidal waveform using a transistor amplifier and an RC feedback network. So observe the circuit. Now look carefully at the circuit. It has two important sections. Section 1, the transistor amplifier, CE amplifier. Components include transistor R1, R2, RC, RE and CE. Its function is to amplify the signal. Section 2, the RC feedback network. Observe carefully. There are 3 capacitors, 3 resistors connected alternately. So this network is responsible for producing phase shift. Basic principle: every oscillator works based on one important principle is called positive feedback. That means a portion of the output signal is fed back to the input in phase. Only then will oscillations continues. Next, Burkhausen condition. For sustained oscillations, two conditions must be satisfied. Condition 1 is total phase shift around the loop must be 360 degree or 0 degree, and then condition 2 is loop gain must be 1, that is A beta is equal to 1. So now come to the working of RC phase shift oscillator. Initially, when the DC supply VCC is switched on, a small electrical noise is produced. This noise is naturally present in every electronic circuit. This small noise acts as an initial input signal. The noise signal reaches the transistor base. The transistor, which is configured as common emitter amplifier this weak signal. Now observe the output. The CE amplifier introduces 180 degree phase shift. That means if the input signal is positive, the output becomes negative. So this is an important property of CE amplifier. The amplified output now enters the 3-stage RC network. Each RC section produces approximately 60 degree phase shift. Since there are 3 RC sections, the total phase shift becomes 60 plus 60 plus 60, which is equal to 180 degree. Therefore, RC network contributes 180 degree. So now let us calculate the total phase shift from the amplifier 180 degree, from the RC network 180 degree. Therefore, total phase shift is 360 degree. 360 degree means the negative feedback is in phase with the original input, thus positive feedback occurs. This positive feedback signal is again applied to the transistor input. The transistor amplifier it once again. Again the RC networks shift its phase again. The signal returns to the transistor. So this process repeats continuously. Hence the continuous sinusoidal oscillations are generated. So why RC section? One RC network cannot provide 180 degree phase shift, so while maintaining stable oscillations. Therefore, 3 RC sections are connected. Each contributes approximately 60 degree. Okay. So in RC phase shift oscillator, the amplifier, usually a C amplifier, introduces a phase shift of 180 degree. According to Burkhausen criterion, the total phase shift around the loop must be 360 degree or 0 degree. So each RC section contributes 60 degree phase shift, hence 3 into 60, which is equal to 180 degree total phase shift. So this figure shows the input and output waveforms of the feedback network. Observe the waveform. The output waveform is inverted 180 degree phase difference with respect to the input waveform. So this 180 degree phase shift from the RC network together with 180 degree phase shift from the amplifier gives a total of 360 degree. Hence the feedback signal is in phase with the input and continuous oscillations are initiated. Frequency of oscillation is given by F is equal to 1 by 2 by root RC, 1 by 2 by RC root 6, where R is equal to resistance of the RC section and C is equal to capacitance of the RC section. So kindly note the key points. Amplifier phase shift is equal to 180 degree, RC feedback network phase shift 180 degree. So total phase shift is 360 degree, satisfies the Barkhasan criterion. So this is why RC sections are used in RC phase shift oscillators. Okay, thank you.